Again, welcome to Java Programming 1. In this lectures, we're going to discuss about searching and sorting an item in an array. So searching items in an array. And searching is the process, again, of looking for a specific element in an array. So for example, discovering whether a certain score is included in a list of a score, it will be a process of searching for that very specific score. Also, searching and sorting is one of the common tasks in computer science programming. And also in a data structure class, there are so many algorithms for searching and sorting because they are the most common two types of traditional computer science tasks. So there are many algorithms and a data structure devoted to searching and also to sorting. So in this session, we're going to discuss only two types of searching method, which is binary search and linear search. Now, linear search means we are going to search an item from beginning to the end in sequential order. So that's why it's called linear search, from beginning to the end. And binary search, first we have to make sure that the items are sorted. Then we are going to divide the item into two and get the middle value. We will compare the middle value with the search key. If that is the correct item, then we finish. Otherwise, if the search key is greater than the middle value, then we go to the greater side of the list of the items. So this means we are not going to search everything. We divide the item into two, and now we ignore the lesser part. Then we are going to look for the middle of the larger part. If the middle is the same as the search key, then we find it. If not, if it's lesser, the middle value is lesser than the search key, which means the search key is greater again, then we go to the greater side. If the item we are looking for, if the search key is less than the middle value, then we go to the lower side. So let's start with the linear search first. So here we have the code here. Consider in linear search, we are using the for loop because we will go through all the items in the array. The array index starts from 0. So here we initialize our counter to 0, and we say we are going to less than the list.length. A length normally will give us the length of the array. So here the array name is list. So we have list.length. So if, for example, the array size is 10, then list.length will give us 10. But since the index starts from 0, it means we have to go from 0 to 9. So that's why the condition here we have I is less than list.length, because we are starting the index from 0, so it will be 1 less the size. So we have a condition here said if the key, what we are searching for is the key. If the key equal to the list index, the index, if it's 10, then from 0 to 9. So if it's equal, then we are going to return the index. The index will be the position where the item is. Otherwise, if we go through all the lists and we didn't find the search key, then we'll return -1. So again, that's the code for linear search for an array, searching an item in an array using the linear search algorithm. We start from the index 0, then we go through the item, then we compare the search key with the first item. If it's correct, then we return the position. If not, we increment by 1. We move to the second, third, fourth index until we reach the end of the array. If we can't find it at the end of the array, then we'll return -1. So a linear search approach, as we saw in the code, compares the key element, the key sequentially with each element in the array list. Sequentially means we start from the beginning of the array list. The method will continue to do so until the key matches an element in the list, or the list is exhausted without a match being found. So in this case, we return -1 in our code. If we find the item, we'll return the position of the item, which will be the index. So if a match is made, the linear search returns the index of the element in the array that matches the key. If no match is found, then the search key returns -1. So we can see an example here. Here we have a list of items. This is an array, 6, 4, 1, 9, 7, 3, 2, 8. Now we are searching for 3, if there's 3 in this list. Again, this is a linear search, so we start from the beginning. We compare 3 with 6, it's not correct. Then we compare 3 with 4, that's not a match. We compare 3 with 1, it's still not a match. We compare 3 with 9, still not a match. We compare 3 with 7, still it's not a match. Then we compare 3 with 3, okay. So in this case, we'll return the index. We stop and return the position, which will be the index of the item. So in this case, it will be 0, 1, 2, 3, 4, 5. So we are going to return an index 5. So we have an example here. Let me see if it will come. Okay, so this is an animation example. So randomly we have an array with 5 items. Now the size of the array is 5. We are looking for 8. So I'll click next. That's not a match. 816. Then click next again. 835, not a match. 898, not a match. 844, not a match. Then 816. So here we are going to return -1 as 8 is not in the list of the items. We can reset it. And this also will give us no 8. Let's reset again, see if we can get our search key. I'm going to use 5. Let's see. 5 is not a match. So we don't have any match. Now, let's reset it. We are going to use 77. So I start next. Then there's a match right there. So we have a check, and they said 77 equal to 77. A key is found with index 0. So it's going to return the index 0. Now again, let's make it 78. So let's make it 72. So it's not a match. Next, not a match. Then there's a match. So 72 is fine. So the whole concept here is that the linear search always starts from beginning to the end in sequential order until we find a key. If we don't find a key at the end, we'll return -1. So that's the method for finding a key in a list. Public static int linear search. We have the array as type int and the key. So with array again start from 0, the beginning. So we start our counter from 0. Then I is less than the list.length. Why? If the size is 10, it will return 10. But the index will be from 0 to 9. So that's why we have less than list.length. Then we compare the first item. If key equal to list 0, then return 0. If not, we increment to 2, then 3 until we find. Again, if we don't find the item, the last thing we are going to return will be -1. So an example is given here. We have an array name list with an item 1, 4, 4, 2, 5, -3, 6, and 2. Now, if we call the function linear search list 4, it will return 1. Even we have 2 also as 4, but the first 4 that it finds, it will return that position. So it will return 1. The next one, we have list -4. There is no -4 in the items. So it will return -1. Next, we have list -3. -3, we have 0, 1, 2, 3, 4, 5. So -3 will return 5. So next we go to binary search. Binary search is very good for large items. It's a linear search. Let's say we have 1,000 items, and the last item is our search key, which means in linear search, we have to do almost so many comparisons. So let's say it means 100 items. It means we have to do 100 comparisons if the item is not in the list or is the last item. With binary search, first, we have to make sure the item is sorted. Then we find the middle value. We divide the item into two. We get the middle value. We compare the middle value with the search key. If the search key is greater than the middle value, then the lower side of the values in the middle, we ignore all of them. So that means if it's 100 items, we are going to take at least 50 items or 49 out. We are not going to compare. Then we go to the upper side. Then we divide again into two, find the middle value, compare with the search key. If it's less, then we go to the lesser side of the. So you can see that every round, we are going to divide the item into two, and we are going to ignore half of it. So binary search is very good for large items because we are not going to search all the items. Always, every round, we are going to divide into two, ignore half of it. So here we say for binary search to work, the element in the array must already be ordered. So it has to be sorted in ascending order. So without a loss of generality, assuming the array is in ascending order, example, we have 2, 4, 7, 10, 11, 45, up to 79. Is sorted in ascending order. The binary search first compare the key with the element in the middle of the array. Then, if the key is less than the middle element, you only need to search the key in the first half of the array, which is the lower side. Now, if the key is equal to the middle element, then you find your match. You stop searching. Now, if the key is greater than the middle element, then you only need to search the key in the second half, which is the larger part of the. So with binary search, we always divide into two. We ignore half of it. So this is example given. We have a list of items. We can see the items are sorted. In linear search, we don't need to sort it because we are going to search from beginning to the end. Binary search, we need to sort because we are going to divide our item into two. So when we divide this item into two, the middle value becomes 4. So we compare 8 with 4. 8 is greater. So if 8 is greater, then we have to ignore 1, 2, 3, including 4. We have to ignore them. Then we go to the upper side, the higher value side, the right side. We divide into two, then we get the middle value. Then we compare with 8. If it's lesser, then we go to the left side of the middle value. If it's greater, then we go to the right side again. So this is what we did, the 8. You can see that 1, 2, 3, 4 is gone. We find a new middle value, which was 7. And then when we compare 7 with 8, we found out that our search key is still greater, so we have to go to the right side. So we left with only 3 items. We take the middle value is 8, then 8 is a match, we stop. So you can see that with binary search, even the item is in 1, 2, 3, 4, 5, 6, 7th position, but we do only 3 comparisons, because half is gone, the next half is gone, then the middle value. So we have the binary search animation here also. So for example, here we have a size is 5. The key we are looking for is 24. So we click next. You'll see that we get the middle value. We compare the middle value with the search key. They are not the same. So we click next. You'll see that it will go to the left side. It went, the reason why, because the search key is lesser than the middle value. So you go to the left side. Then here also it's not a match. The next is not a match, so we didn't find it. Now let's reset it. And then let's use, let me reset again. Let's use 77. or 99. So I'll click next. You can see it's not a match, but you will see that next we are not going to the left side no more. We go to the right side. So when I click next, and there was a match, 99. So we ignore the lower side. Now next time I'm going to take lower value. Let's use 24, and I'll click next. You see that it will go to the left side now, and I click next. Then there's a match. So that's the binary search. Again, we have another example here. We have a search key 11. First of all the items are sorted. We find the middle value. The middle value is 50. Since the middle value is greater than the search key, we go to the left side. So we come to the left side here, and we look for the middle value. Then the middle value was 10. And we can see the middle value was 7, 2. Then we compare with the search key. The key is 11. So if it's 11, to go to the right side because 2, 4, 7 is too small. So we go. So when we go here, we have 3. The middle value is again 11. So that matches our search key. So 11 is what we are looking for. So the whole concept is first binary search, all the items have to be sorted. We take the middle value, compare the middle value with the search key. Since search key is less than the middle value, you can see that we ignore 59 up to 79. We ignore all the higher values. We go to the left side. Then we find our middle value. The middle value was 7. Is 7 greater or less than 11? No, 11 is greater than 7. So I have to go to the right side now. So 2, 4, and 7 will be ignored. Then I'll go to the right side. The middle is 11. It's 11. So 11 is the same as 11. So we find our location, which will be number 4 position. And the same concept here. Another example, the key is 54. So the same items. This time we ignore what? The lower side, because the key is greater than the middle. Then when we come here, we get our new middle to be 9, which is 66. And now 66 is greater. So we go to the left side, and then we compare middle 7. Here we didn't find our match. There's no 54 in the list. So binary search method return the index of the element in the list that matches the search key if it is not contained in the list. Otherwise, as we saw, it will return -1 if the item is not inside. Also, the insertion point is the point at which the key will be inserted into the list. And this is the coding. So here we have a variable named low. We initialize it to 0, which will be our lower side. The higher side will be the list -1, the index. So if the item is 10, the highest index will be 9. So our lowest index is 0, the highest index is whatever the size is -1. So now we check why the high is greater than or equal to low. This condition tells us that we haven't reached the end of the index because we start from 0 to 9. So if 9 is greater than or equal to 0, we haven't finished. So we find the middle value, so it will be low plus I divided by 2. When we get the middle value, we compare with the search key. So here we say that if the key is less than the least middle, which means the middle value greater, then we go mid -1. So what we are doing is that we are taking the lower, because here the key, since the key is lower than the middle, we are taking the higher side out. So instead of the high to be 9, we will say the high is the middle -1. So if the middle is 4, the high now will be the middle -1. So we are not going to, if it's 9, we are not going up to 9 no more. We go up to 4, 3. So else, if the key is equal to the middle, then we return the middle. Otherwise, we go the higher side. So if we are going the higher side, it means we have to ignore from the low, which is 0, up to the middle. So we go middle plus 1. So low equal to middle plus 1 means we ignore half of the low side. And mid minus 1 means we ignore the middle side to the highest. So that's the whole concept here. 3 options. So also, since binary search is a very common algorithm in searching, Java also provide several validated binary search method for searching a key in an array. So we can use binary search, which is part of java.utility package, arrays.binary search. Also, we can do sorting. Sorting is like searching. By sorting, we are rearranging the items, either ascending or descending order. So we have example of selection sort. The concept of selection sort is that you go through the list. When you find the smallest value, you swap it with where it's supposed to be. So you can see this selection sort. We go through the list. So 1 is the smallest, so we swap with the first one. Then we start from here, look through 2 is, so we swap with 9. Then, okay, 4 is the smallest, we swap with 5. So we keep going all the way to the end. Again, in data structure class, we're going to discuss about different types of sorting algorithm, such as bubble sort, radius sort, quick sort, insertion sort, merge sort. We have up to somewhere around 10 different search and sorting algorithms. So this is already a built-in sorting and searching. We have binary search, we have sorting algorithm that is a built-in method in the Java utility package. So array is also a data structure that represents a collection of same types of data. And actually array is one of the simple data structure. In the data structure class, we're going to talk about different types of data structures such as queue, stack, tree, etc. But array is the beginning of the data structure class. So here I can create an array, name my list, and the type is double, which means the size is 10, which means all the values here will be data type double and 10 items. And the index is from 0 to 9. So this will be the conclusion of this lecture. Again, we already went through what is an array. We talked about how to declare an array using the loops. We can print an item from array. Using the loops also, we can go through an items in an array. We did that lectures already. This lectures is only for how can we sort and also search an item in an array using Java built-in package, java.util. So again, wish everybody the best. This is our last lecture for Java Programming 1. We're going to start with the Java Programming 2 soon. And the first topic in Java Programming 2 will be inheritance. We know object-oriented programming, there are 3 main attributes or characteristics or the features, which is encapsulation, polymorphism, and inheritance. So that will be our first topic in Java Programming 2. Again, wish everybody the best. Thank you.